room. Hello, greetings, welcome. I'm here to talk a little bit about low Earth orbit satellites. I'm joined by my colleague Raj Singh, who's online with me as well. He'll be speaking as well, and also my colleague Adrian is in the room there, and he will be coming up when we get to the time to speak about questions and answers. So, greetings from the United States. I'm coming at you by the beauties of the internet and what we're doing here. So let's get into our session. Raj and I are going to talk a little bit about LEO satellite constellations, and then we'll have some time for questions and answers at the end. So, okay, here we go. So at the Internet Society, we believe that the internet is for everyone. It should be, and that we look at how do we connect the unconnected all around the world in various different places. So this year, we've spent a lot of time looking at what are these low Earth orbit satellite systems? What are these systems all about? If you've been watching on the news, you've certainly seen a lot about, especially lately, Elon Musk's SpaceX, their Starlink service, and whether it's in the Ukraine or whether it's in other different parts of the world, there's a lot of attention paid to it, but they're just one of many systems. Amazon has its Project Kuiper that will be launching later this year that will be providing the service. There's another service called OneWeb, Telesat. There's a couple of different services they'll be launching out of India, out of China, out of other parts of the world. So many different satellites, systems that people are talking about. So there's a lot of interest because traditionally satellite internet access has been from what we call geosynchronous or geo orbits, 36,000 kilometers away from the Earth. They've often offered high throughput, but you can't do something like a Zoom call over a traditional satellite connection. It's just not there. It takes, the physics work out in a way that it takes 600 milliseconds or so for a signal to get to that satellite and back. Whereas LEO systems offer low latency connections. We can do calls like this. We can do gaming, esports, virtual reality, all of these different services that are so much a part of what we're looking at today. Here's a quick illustration showing you what's happening. That little zone over on the left, right above the planet from up to 2,000 kilometers, is the low Earth orbit or LEO space. And that's where most of the satellites that we've launched are there. It's where the astronauts are and the space stations that are up there. It's all of that happens in low Earth orbit. And then you have at the far right, the geosynchronous or geostationary space, where you have satellites that orbit and one satellite can basically stay in place over a particular spot on the Earth. And so you can get, with about 3 or so satellites, you can get coverage of the entire world from a geosynchronous point of view. And in the middle is the middle Earth orbit or MEO. And there are a couple of systems that are there that have satellites in the MEO space that are used as well for internet access in some way. Well, because these systems are down in the low Earth orbit, orbiting right above the planet, they need a lot of them. You can't just have 1 or 2 or 3 satellites out at the geosynchronous area providing connectivity. And so in the language of these satellites, there are constellations of these systems. Right now, the main constellation that's up there right now is from Starlink, from SpaceX. They have about 2,800 operational satellites up there right now. They're on the path to go to as many as 15,000 satellites. Amazon has their Project Kuiper with similar plans. So, and others too. Tens of thousands of satellites may be orbiting the Earth in this kind of large-scale mesh of constellations of satellites that are out there. There's a lot of interest, partly because we have had a great amount of advances in rocket technology. Now, there was a push back in the early 1990s to launch a whole number of systems that provided low Earth orbit access. But the economics have changed. So now where it's much easier to launch, it's much easier. You can now mass produce these satellites rather than developing them each individually. And there's companies such as SpaceX and others that provide all of these services all together and have really revolutionized how it works. Our question from the Internet Society, and I think for all of you at the IGF as well, is sort of, okay, we can get internet access, but are these good for the open internet? Are these just okay another way, or are they actually bad for the internet in some way? What can they do? this was the task we set about ourselves at the beginning of this year in 2022, trying to figure out and to ask questions. We've seen many opportunities. I think I'll turn it over to my colleague Raj to talk a little bit about some of what we found.
Thanks, Dan. Hello, everyone. It's good to have you in this session today. And, I hope you've had, I think a lot of us at the regional IGF and within the region at large, of course, have quite a bit of interest in ensuring that connectivity remains core to what we do, because, without connectivity, we can't have the internet. Now, when the LEO satellite industries, started emerging, it's a very new industry. Obviously, there's still a lot of questions, and some of the work that we're currently doing is looking at how do we answer some of those questions. But I must admit, we have more questions than answers at the moment. But nevertheless, if we look at it from the opportunity perspective, now you may be aware of the Internet Society's community networks related projects that we've been doing, which we in fact started in the Asia Pacific region way back in 2009, 2010. So, in each of those instances, whenever we've deployed community networks, it's always been highly problematic to get backhaul, to get services where people need it the most. Now, we're looking at remote areas, we're looking at rural areas and underserved areas. I should also add here that it's not just about developing and emerging economies that face this issue. In the developed countries, I'm coming at you from Australia today, it's a vast continent and we are sparsely populated. And we have some very large farms, for example, and other parts of the country where connectivity is very poor. As it is, we've been relying on satellite access in the past, but LEO satellites, I think, bring about a whole set of new opportunities, including, when it comes to things like environmental monitoring, agriculture, quite apart from, of course, access to information and all that the internet empowers. Now, moving on from that, we have also in this region, we've got small islands, we've got the tallest mountains, we've got desert, we've got forest, we've got jungle, we've got everything. And therefore, we have communities that live in these sort of areas where, again, having that backhaul in place is just not possible. So again, that's another opportunity for LEOs. And I've already mentioned how backhaul is so critical to community networks. And, when you have a village on the top of a mountain or at the bottom of a valley, getting connectivity through fiber or other means or even copper cables is very difficult, not impossible. So, satellite does provide that opportunity.
And I live in a... Oh, go ahead.
Yeah, just prior to our session, this session, we had about our friends Jeff and talked about Lex and the work they've been doing in Cebu and the Philippines. And Asia Pacific is also, of course, it is the world's most disaster-prone region. And again, having that connectivity availability becomes a major issue whenever we have an instance of a natural disaster. What is needed is rapid response, right? We can't wait days and weeks for connectivity to come back up. What you want is to deploy quickly. And again, this provides us with a complementary, be it a stopgap, an interim measure, but at least so we can get things going. Dan, you wanted to come in.
Yeah, I was just going to say, I agree with you too, that it's not just developing or others. It's, I live in the East Coast of the United States, but yet where I live, just 15 minutes away from me, there are people who are not able to get any kind of broadband connectivity purely for the economics of running the wires and such. And so it's a fascinating opportunity. It's there. There's also organizations I work with here in the US that do a lot of disaster response for wildfires or for other things. And they have embraced already the fantastic capability they have of being able to go and basically take a pickup truck with an antenna on the back of it and be able to go and start and set up a command post that's wired back into their central facilities to coordinate what goes on. So tremendous capability. The question, of course, that we've had is, as you said, as Raj said, this industry is only just beginning. Really, there's only one major system out there, SpaceX's Starlink, that's offering a commercial service. There's others. OneWeb has a number of its satellites up there. Amazon is planning to launch later this year. 2023, 2024 are going to see the launch of probably 5, 6. There are as many as a dozen different systems that are being proposed and are in the works. So there's a lot of questions. And we have them on many stages. I think, Raj, I'll turn this one to you to talk about some of the business pieces.
Yeah, so as we were looking into this work, which of course my colleague Dan is leading internally at the Internet Society, as I mentioned earlier, we had more questions than answers. But I think it's important to ask the questions, right? Because so that we go prepared into this as as the wider community on what we're embracing, what some of the opportunities are. There's no doubt there's immense opportunities. We've already touched on some of those, but there are also some challenges that I think what we've learned from past ways in which technology has evolved. It's nice to be cognizant of, okay, what is possible and what is not possible, and what some of the things that will be thrown up that we need to deal with. Now, affordability still remains an issue, I think. If you look at how the LEO industry currently is, you need to buy a ground terminal, you need to pay a subscription fee per month. And the problem still remains, of course, is that, for some of the communities that need this connectivity the most, even that, let's say, $100 a month or $110 a month, I think roughly, is what we're getting at the moment from Starlink, that still is quite expensive, right? Particularly for the areas we are looking at. The ground terminal itself. And then, of course, don't forget that that equipment also needs electricity to run it, right? So the other problem we have in this region, as well in other parts of the developing world, is that we don't have reliable power supplies. So now how do you deal with that as well? So that all adds up to the affordability issue. Then, of course, there's capacity issues. Already we're seeing some reports from the current commercial providers, users who are on those systems, that there is some congestion starting to happen in some of those areas. Yeah, it may be because the satellite got knocked out, or maybe some other transit or routing issues. But the fact remains, as more users come online, the satellite providers themselves need to ensure that there's enough capacity in the system to meet what users' expectations are. Now, notice I didn't say users' needs are, I said what users' expectations are, because that, that very quickly needs change into expectations. And then, things go downhill when things are not as they were expected. Competition is interesting. Dan mentioned a few potential players who are launching or in the process of launching or doing pilots at the moment. But, with competition also comes consolidation, somewhat later, but it does end up there. And, one of the other questions that arise, as we're seeing in other parts of the internet ecosystem, is, what happens? Competition is great, but then at some stage, these companies cannot sustain themselves and they get taken over by a bigger player or some other player. And then consolidation comes our way. So what does that mean for the future then? Will we suddenly have 1, 2, or 3 companies that will control all LEO satellite orbit slots and connectivity around the world? I'm not so sure that's the sort of outcome we want. And then there's the policy side of issues. If you have an ear to the current discussions around ITU, for example, and the World Radio Conference coming up next year, there's a lot of chatter, a lot of discussions about spectrum allocations and how there is going to be interference. It's a bit of a, well, I can't call it a land grab, it's a spectrum grab, I suppose. You've got the mobile operators, you've got satellite providers, you've got a whole bunch of the military as well, I should add. Everyone's interested in spectrum. And, how do you, one, allocate that spectrum efficiently, but also ensure that, you maximize and leverage the benefits that will come out of that use of that spectrum, right? Interference obviously is part and parcel of that. We have cases where, some people are concerned that there will be interference, whether, stretching from military systems to aviation systems and others, and of course, existing mobile operators as well. So there's a lot of questions in and around this. And then, of course, there is the allocation of orbits themselves. I mean, currently it's largely unregulated. This, I would call it fuzzy. I mean, that's the best way I could put it at the moment. And how many orbits are too many, and what happens when orbits start colliding? Right now, let's hope that it doesn't get to that. But no, there are questions that we need to answer. But most importantly, I think one of the bigger challenges I see, or we see, I should say, is around geographic restrictions, because you see each country has its spectrum regime, and they have their license regime locally for providing connectivity. Now, when so in order to a satellite provider to provide connectivity within a country, it's not just because you've got a satellite up in the sky. You can beam your signals and provide connectivity everywhere. It doesn't quite work like that. So there are regulatory issues at play as well. And, for example, the current the only commercial provider at the moment, they're having some challenges with some countries in the region and elsewhere, simply because they don't have a license to operate. Just because they're up 2,000 kilometers up in the sky doesn't mean they don't need a license to provide connectivity at the local level. So that also becomes quite problematic. And I think there needs to be some rationalization as well as a bit of harmonization in how all these are treated. Again, we said this is a new industry, it's an emerging industry, so obviously there will be a whole bunch of questions that need to be answered. We've talked about business policy, and let me throw it back to Dan for a bit of the technology challenges that.
Yeah. And I think what you said there at the end, one of the challenges we've certainly heard from some of the industry is the fact that you're right. They have to go to, 200 plus countries or economies to get permission to operate in each one. And it is a sizable amount of work to be able to go and try to be able to operate one. From a technology point of view, there's nothing that prevents their signal from beaming down into any particular region and to be received by an antenna there. But it comes down to the geographic boundaries, the restrictions, the spectrum, all of that, which for folks, for people attending an IGF, we haven't typically in the past thought about spectrum as much, or things around that line. But this is where it all comes into when we're looking at the LEO-based access. A lot of the technology, it's interesting. There's security concerns, privacy, interoperability. Probably the largest concern, and this is one that's being addressed, but it's certainly a big one, is space debris. Is these issues that are up there, these satellites, the LEO satellites, typically only have a lifespan of around 5 years. And after that, they need to, as they say in the industry, deorbit. They need to come back to Earth where they burn up in the upper atmosphere. So there's all of these things happening, and if they lose control of one, what happens to it? A lot of planning and thought, and there's a number of different UN agencies and pieces that are part of that make it sense. But these are all concerns and questions we have to think about. There's a lot of other questions we have, like we don't know, are all these business models sustainable? I mean, this could be said of any new industry, right, of providing this. It's not unique to LEOs, but it's just an ongoing question as the Internet Society of will all these work? What's going to be the impact on ground-based providers? It's a new form of competition. I know a number of people who subscribe to my current internet service provider, my broadband one here, who'd said they'd drop it in a heartbeat if they had a really good, LEO's connection that was solid that they could count on. What's the environmental impact? There's a lot of concern and questions around, the launching, the pieces there burning up in the upper atmosphere. There's a lot of studies and pieces that we just don't know. There's concerns about astronomy. And we talked last week with some folks who were involved with our community week in the Internet Society, and it talked about, it's more than just painting them black or something, but it's doing other things to ensure that the solar arrays aren't working. There's a lot of pieces around that collectively we have to work out as we move forward on this. There's so much potential, and the question is really, how do we shape that future? I want to leave time for questions, so I'll just end it by saying that, as we all go into this collectively, the internet community, all of us here at this IGF, at the other IGFs happening around the world, in organizations like the Internet Society and others around there, we are all learning. So one of our requests certainly to all of you is, as you learn more, as you work with this, share that information with others. If you've learned a bit out of this or thought about some new questions, share that with other people, help inform it, because we collectively, if we're going to provide internet governance that includes LEO-based, systems, we need to have a knowledge and a base level of understanding there, and we need to help people on that. If you're able to deploy pilot programs, if you're in your country or your region, is able to go and do some pilot programs, I think it's great. Everybody should figure out how to get that access, and then share your experience, please. Let people know how it worked for you, how it didn't work, what's there. Help collectively to answer all of these questions. We at the Internet Society have a document in development that provides our perspectives on these systems. We've developed it with input from our organization members, from our chapters, from others all around the world into this. We anticipate publishing that by the end of this month, and there's a URL up here where you can go and find that. But with that, I think I would like to turn, I see my colleague Adrian has come up on stage. And so we would gladly open it up to any questions that people have.
Thank you, Dan. Does anyone want to ask any question to Dan or Raj about LEOs?
And not just questions, if you have feedback as well on what your thoughts are on this, I think that's also quite welcome.
Is there anything you don't understand? You didn't understand about the technology, the implications? Yep, we have one. Oh, you can do that, yeah. No? Okay.
Hello.
Okay,
Yeah.
good.
Good morning. Thank you for the presentation, and it seems the project has an amazing potential. Can you share perhaps your thoughts about the timetable on when we can roll out this amazing potential? How many years?
Well, so I don't know the specifics of the availability. So let's be clear. We at the Internet Society are not launching our own satellites as much as we would love to, or something around that. But the commercial services, for instance, SpaceX has their Starlink service available in many parts of the world now. Last week, we had a colleague, we had somebody from the Internet Society chapter in Australia who was joining our session actually from a location in the rural Australia. She was coming in over a Starlink connection and was able to participate in a Zoom call very much like this and be able to work with it. So it's here now. Again, to Raj's point earlier, there are some affordability issues. There are some questions around that, you know, if you can be able to afford it, it's there. I don't know the rollout across their particular country. I mean, the countries in your region, excuse me. If you go to Starlink's website, they have a map that shows where it's coming in there. Now, the first one is up there now. OneWeb is another service that's starting to explore commercial operations. They have a little bit of a different model. They're not direct to consumer necessarily. Amazon's Project Kuiper, they're planning to launch their first 2 satellites later this year, and then looking at making service available next year and the year after in that kind of space. So over this next two to 3 years, I think we will see connections from probably a half dozen of these different services that are out there. So that would be the timetable, I'd say. Whether they come to your particular country goes back to the question that Raj was talking about with the spectrum and the fact that they have to go to every single country to get permission to operate in that country and get approval and licensing from the regulators. So in some parts of the world, that's taken an extremely long time. And so Starlink, for instance, is not yet operating in those countries because they can't yet get that regulatory approval.
Yeah,
Thank you.
So the regulatory issue, I think, is the biggest challenge at the moment, and as well as the operational model some of these providers have. You know, they want, for example, what the ownership rules are for a telecom service in a particular country. That's also a regulatory challenge some of them are facing. You know, many countries don't allow foreign-held telecom companies to operate in their jurisdiction. So it's got to be majority locally owned. So that's another challenge, particularly in the Asia-Pacific region, that we're also seeing.
Thank you. Thanks for the question. Over to you, gentlemen. Please briefly introduce yourself so we can know a bit about you.
Thank you. It's Andrew from the regulators office in Vanuatu. I think Raj just sort of touched base on what I was going to ask. But thank you, Dan and Raj, for sort of presenting this to us today. So the question was on regulatory. I'm not sure whether there are any countries who have had this experience already that you might know of, because for us in Vanuatu, we are still struggling at the regulators office to look at the regulating these opportunities, especially when they come they come in for the domestic market as a retailer, not a wholesaler option. So, and it's interesting how these things are happening, because eventually you will have a cell phone that can be used across the globe on the satellites. And how do we regulate this? So these are the things that I think needs more discussion probably at the Internet Society. Thank you.
So I can give you examples of what currently happening. So in Australia, for example, they can provide services in designated areas. So as per what we've seen from the current license conditions, they can't provide services, or they're not providing services in built-up urban areas. So anything outside that, and there's a particular map. If you go to this to the website with SpaceX and Starlink, there you can see where they do provide in Australia. And it's not the whole continent at the moment. They're still working on that. And New Zealand, I believe, is another country where they are able to provide services, again, as a retail provider. My understanding is that there are a couple of Southeast Asian countries they're currently working with to provide services, but it'll be through a local entity or a local company, and where they're just providing either backhaul or as a wholesaler to those companies locally. So there's no one model that we're seeing. And I think it's also because the regulatory landscape is not harmonized across the region, right? Each country makes its own decisions on what it wants to do and how it wants to do it. So, and I think it's very important. And thanks, Andrew, for the question. And coming from a regulator, it's even more pertinent that, because obviously if the regulator is thinking this, then the rest of us should be thinking about this as well. Dan, maybe you've got some thoughts from other parts of the world.
Yeah, I was going to say, this is the challenge is there isn't a harmonized, as you said, a harmonized regime. So every country is doing it, looking at what their own, restrictions, what they want to do and what's in there. I think we will also see different business models, because, we are seeing, Starlink is direct to consumer right now, primarily. They have some other options, but they're primarily in that model. Some of the other ones who are coming on are looking to be more of the wholesale model, providing backhaul to existing providers in different spaces. So I think each one of those is going to provide a different kind of regulatory requirements, and it will be a very interesting, challenging space for you as a regulator, I think, to look at how does this work, what makes the most sense. I'll mention the point you said, satellite phones. To the point when if we get there, we're already seeing a lot of interest in that. We're seeing it even with more recent announcements around emergency messaging, but we'll see more. That certainly, I think, for many of the phone providers and others, sort of the end game, is how do we get there to where I could take my Android or iPhone or whatever and be able to have connectivity wherever. When we get there, that definitely does create a whole new layer of regulatory and just general concern. We're not there yet, and I think we're a good number of years away from that. But it is certainly something that we need to be thinking about on the distant horizon. I know we're running low on time. I don't know if we have time for one more or.
Yeah, please.
Hi, it's Chen from Taiwan, and I want to ask about, because from the information you just provide, it seems there will be a lot of satellite to be sent up to the space, and when the number of the satellite is coming up, and it will most be some issues when they crashed or they're broken. So what will be this issue will be resolved, like, because who government the space, that it seems like who can determine the problems or to fix it, that how will be possible?
Yeah, there's a huge amount of work around this happening within the UN in particular. There's a group, there's an organization entity there that's focused around this. There's also work within the ITU, within some of the different pieces that are here. A lot of this happens, and it's also happening on a national level. I'll speak here in the United States. The way it works is that if you're launching a LEO constellation, you need to first get approvals and orbits from the regulator in your nation, in where you originate. That's the first place you need to get that. You need to get the permission to launch and to put your satellites into certain shells, as they call them, certain orbits and pieces like that. So here in the United States, entities like SpaceX and Amazon have to go to the United States Federal Communication Commission, FCC, and they are the ones who regulate that and do that. they have just made a declaration that they will be basically later they'll be doing some rulemaking that will say that all satellite companies must have, if their satellites have been dead, they must have a plan to get rid of them, to remove them within 5 years of them going dead. And they're putting that in as a requirement for operation. So you must have a plan that you will do that. When we've spoken to the companies, they are planning on that. They're looking at how do they go and deorbit, how do they go and remove these from orbit as quickly as they can. I think everybody recognizes that space debris is a great challenge, because those dead satellites could wind up hitting other satellites and creating other kinds of challenges that are there. So there's a lot of effort around that happening at the UN, at the national level, at the industry level, and it is definitely a concern that I think people are looking at and taking extremely seriously. I think with that, we're at the end of our time. So I'd just like to thank you all. I'd like to thank my colleague, Adrian, who's in the room, and Raj, who joined us from Australia. And thank you all for the work that you're doing there at APrIGF.
No,
Thanks very much,
everyone.
everyone.
Cheers.
Thank you, Adrian. Thank you, Dan and